let's spend some time on this because this is a practical interpretation. So you all need to understand whenever we are going to perform an image. Now this will be, uh, this was I think 70 to 80 slides for LFT. That was at the level of maybe hepatologist level. So we have sorted out about 15 slides so that we can have a basic understanding about. We won't be able to go into the hepatologist depth, but at least we need to understand 10% of what hepatologist is going to be interpreting it as. So, aminotransferases is an ASTs and ALTs, aspartate aminotransferase and alanine aminotransferase. What would be the comparison? What would be the important set of points which would be important for us to understand, to interpret this? Aspartate transaminase aminotransferase is there release in the cytosol at the mitochondria. This is there in the cytoplasm only. These are some of the theoretical points. Now remember, AST can also be released by heart, skeletal muscles, kidneys, brain, pancreas, lungs, WBCs and RBCs. So these ASTs are also there in other cells. So we may not have ASTs if it is elevated marginally, whether it is coming from liver, skeletal muscles, kidneys, brain, we don't know. But ALT is more specific for liver. So alanine transaminase or aminotransferase or SGPT is more specific for liver. So it is more sensitive and specific than ASTs for liver disorders. More sensitive. So alanine transaminase is more sensitive and specific, and its half-life is also more. So it remains elevated for a longer period of time for us to understand whether liver pathology. So half-life is 17 hours and 47 hours. This is what is more a theoretical point, but important point in case of this particular slide is ALT or alanine transaminase or aminotransferase is more specific for liver, whereas AST can also be there in other disorders, other